right, so now we're going to go through the free response solutions. So number 18, insulators. Ceramic engineers are testing a new formulation for the material used to make insulators for power lines. They will try baking the insulators at 4 different temperatures. So we've got 4 different temperatures. That's probably going to be our levels here. So one of our factors is going to be temperature at 4 different levels, followed by either slow or rapid cooling. So we have another factor of the cooling method at 2 different levels, slow or rapid. So we've got 2 different factors. We got the baking temperature and the cooling rate, and 4 levels, 2 levels. So altogether we should have 8 treatment groups here. Okay, they want to try every combination of the baking and cooling options, our 2 factors, to see which produces insulators least likely to break during adverse weather conditions. So what are the experimental units? So what are we experimenting on? In this case, it's not people or lab rats or anything. It's actually the ceramic insulators. I guess I can delete that. Whoa, what just happened? Okay, so material for the insulators. How many factors are there? Well, we have 2, the baking temperature and the cooling method. How many treatments are there? Well, there were 4 levels and 2 levels, so 4 times 2 would be 8. So we'd have 8 altogether. What is our response variable? That's what we're measuring, which is how long they last, or whether or not they're going to break. So likelihood of breaking during adverse weather. Sweet potato pie. Sam is preparing sweet potato pies as his dessert for Thanksgiving. This would have been great if we did this before Thanksgiving. So the store he shops at sells 6 sweet potatoes in a bag. He found that each bag will contain 0, 1, or 2 bad sweet potatoes. Based on his experience, he estimates that there will be no bad sweet potatoes in 40% of the bags, 1 bag sweet potato in 30% of the bags, and 2 bad in the rest. So we had 40 and 30, which is 70%, meaning an additional 30% that are going to be in the rest. Conduct a simulation to estimate how many bags Sam will need to purchase to have 3 dozen good sweet potatoes. So he's looking for 36 good ones, and how many bags does he have to buy before he gets 36 good ones? All right, describe how you use random number table to conduct the simulation. So we're going to, because we have numbers that are all ending in 10, like 40, 30, and 30, we can actually use numbers 0 through 9. I'm going to assign 0 through 3, which is going to be for no bad, so we're just going to say 6 good. And then 4 through 5, 6, is going to be having 5 good. And then all the rest are going to be 7 through 9, which are going to have 4 good, which are going to be 2 bad sweet potatoes. So you can look at this from positive, from good, or the number of bad, which would be 0 bad. This one would be 1 bad, either way, or 2 bad. Okay, cool. So that's how we're randomly going to assign, or not randomly assign those. That's how we're going to assign our the outcomes of the trials. The wording on this is so critical. All right, and annoying. All right, show 2 trials by clearly labeling the random numbers given below. Okay, so the first one we had was 5, and if we go back, 5 was, actually, let me copy and paste this. It's all on the same page for you, which makes it a lot easier, but for me, it's not. So let me put this over here. There we go. That way I can reference it. So the first one we had was 5, which meant that it had 5 good ones. So I'm going to put 5 above that for 5 good ones. And I'm going to do a running tally as I go. That might make this easier. 7 was 4 good ones, which would be put us up at 9. And then 8 is 4 more, which is going to put us at 13. 2 is going to be 6 good ones, which puts us at 19. Remember, we're trying to go up to 36. 1 is 6 good ones, which is going to be up to 25, and 7 is going to be 4 good ones, which puts us at 29. 6 is going to be 5 good ones, which is going to put us at 34, and then 3 is going to be 6 good ones, which is going to put us over the edge at 40. So 3 was the last one that we had. So how many bags of sweet potatoes did I have to buy before I got 36 good ones? At least 1, 2, 3, 4, 5, right? And 6, 7, 8. So our outcome was 8 bags of sweet potatoes. Okay, so that was one trial, and the length of the trial was 8. That was our outcome. And then at the end, we're going to take an average of those two to say, on average, we're going to have to buy 8.5 bags of sweet potatoes before we have 3 dozen good ones. All right, same thing on this one. I know this is a little tedious, but hey, you do it once, cry once. All right, so there's 6. We got another 6, which is going to put us at 12, zeros, and another 6, which is 18. Hey, this one's going fast. Another 6, which is going to put us at 24, and then 6 again, which is 5, which is going to put us at 29. All right, so this one's probably going to put us over, or no, never mind. 6, which is going to put us at 35, so we're almost there. This one will put us over whatever it is, which is 5 more, which is going to be 40. Okay, so this was the 7th one. Okay, so we got 5, 6, and 7 was our outcome. So state your conclusion. So on average, we're expecting to have to buy 7.5. So we just add them together, right? So 15, oops, I do that quite often. 15 divided by 2 is equal to 7.5. So on average, we're expecting to have to buy 7.5 bags of sweet potatoes in order to have 3 dozen good ones. All right, grape juice and blood pressure. Researchers who want to see if drinking grape juice could help lower their blood pressure got 120 non-smokers to volunteer for a study. Interesting. So it looks like right off the bat, we're blocking by non-smokers. If we did a separate one with smokers, then that would be something else. So you could say if we were blocking because we were using non-smokers and smokers, or if we're only using non-smokers, then in that case, you could say it's just one of the factors that we controlled. We didn't look at the difference between smokers and non-smokers. We only want to know about non-smokers. All right, they measured each person's blood pressure, and they randomly divided the subjects into 2 groups. Okay, so we got 2 groups, means there's 2 treatments, right? One group drank a glass of grape juice every day, while the other one did not. So you have your placebo. Well, placebo would be whether or not they got to choose what they did, but you could also do it as a control. So whether or not you did or didn't drink grape juice every day. After 60 days, researchers measured everyone's blood pressure again. They reported that the differences in change in blood pressure between the two were not statistically significant. So that's our conclusion here. There might have been a difference that we observed, but based on the sample size, it wasn't statistically significant for us to say that it could not have occurred by chance, which is keywording there. All right, what is the experiment? Was it an experiment or observational study? Key to an experiment is random assignment treatment groups. Did we randomly assign, randomly divide them into 2 groups? Yep, we're good. So it is an experiment. Explain briefly. So the key is that we randomly divide them into 2 treatment groups. That's what makes it an experiment. Briefly explain what not statistically significant. Okay, so that means that the differences that we saw, the observations we saw, could have occurred by chance. So it wasn't a big enough difference between the two, which we call effect size, but it wasn't a big enough difference between the two for our sample size for us to believe that it was not statistically significant. We will show next semester how to find that and quantify that with probability values. Should be fun. Briefly explain why researchers randomly assign treatment groups. That's to control for outside sources of variation. I think I actually type those, yeah. So if you want to see the actual typed out solutions, wouldn't that be helpful? There you go. Should I read them to you? That'll just take more time. Did I do it for this? Yeah, I actually did. I don't know why I didn't just click on that. So you're welcome. You can read those if you want. All right, so randomly assigning subjects to groups allows us to equalize the effects of unknown or uncontrollable sources of variation. So we're just controlling for outside sources of variation so that we can basically isolate down to the factors that we're interested in at their different levels, so that we can say, hey, fear is not a factor for you. It's kind of funny. All right, since everyone's blood pressure was measured at the beginning and the end of the study, researchers could have simply looked at the grape juice drinkers to see if the blood pressure changed. So again, you could have differences between just seasons and stuff like that. Everyone's blood pressure is going to be elevated if you're around family. So sad. I'm so sorry. Didn't mean to bring that up. All right, so the control group provided a basis for comparison after 60 days to determine if the groups drinking grape juice had lower blood pressure because of the juice. Maybe everyone's blood pressure naturally drops at a certain time of the year. I don't know. Briefly explain why the research studied only non-smokers. Okay, so maybe they thought that smokers would have other underlying health conditions that might add large amounts of outliers, so add large amounts of variation to our study. So if we wanted to see if there was a difference between it, we could have studied, we could have blocked by smoking and done 2 parallel experiments, to smokers and non-smokers. But we were mainly concerned about outside sources of variation. Alrighty. Other researchers now plan to replicate study using both smokers and non-smokers. Okay, blocking. Draw a diagram for an appropriate experiment. Okay, so we're going to block. So I didn't actually draw the diagram for you, but essentially at the beginning, we're blocking by smokers and non-smokers. Then we assign two random groups, grape juice, no grape juice for both of them. At the end, we compare and see the differences between the two. 21. Cloning. After a polling organization is investigated in public opinion about cloning. You phone a random sample of 1,200 adults, asking each person one of the following questions chosen randomly, so one or the other, A or B. Which question do you think will elicit greater support for cloning? So what kind of bias is that? If we're talking about the wording, remember that's response bias. It's the juicy, the fun one to talk about. Do you favor allowing doctors to use clone cells in attempts to find cures for such terrible diseases as Alzheimer's and Parkinson's? Oh, the heartstrings, which I have none. Which question do you think will elicit greater support for cloning? So obviously that's going to be A. I didn't even have to read number 2. Should research scientists be allowed to use clone human embryos in their experiments? That would be more straightforward, or maybe even biasing towards the other way. If there's a way to word it neutrally, I don't even know. Moods. A headline in New York Times announced research shows running can alter one's mood. The article reported the researchers gave a personality assessment test to 231 males who ran at least 20 times a week and found statistically significant. Oh, it was statistically significant. Okay. Personality differences between runners and the male population as a whole. Do you think the headline was appropriate? So on this one, if we're going to say there's a causal relationship, meaning if we're trying to claim if you start running, it'll change your mood. Then it has to be done by an experiment, not an observational study. So observational studies can say, hey, there's a trend that people who run tend to be happier, but maybe it's that they run because they are happier. And because if they were depressed or they weren't feeling as happy, they'd be less motivated to go out and run, right? So this would be what we would say correlation is not equal causation. There might be a correlation between the two, but we can't prove a causal relationship until we randomly assign treatment groups. So we got to take a random group of people, assign them to either do running exercises or not do running exercises, and then compare their moods at the beginning and their moods at the end. Okay. So again, is there a conclusion? No. The main issue that we have here is correlation does not equal causation. So again, you can say that the observational study, which is what they actually did, showed that there was an association between the two, but in order to prove a causal relationship, you have to have an experiment with randomly assigned treatment groups. All right, that is it. Whew, that was long. I'm definitely going to break those out into separate videos so you can digest it slowly and skip whatever parts you feel like you don't need. All right, I will see you guys later. I hope you guys have a Merry Christmas, and the second semester can't possibly be worse than the first semester because the only way for that happens is if I don't see you ever again, which would be really, really sad and is very depressing to me. So this has been a hard semester for me. I think it's probably been hard for you as well. I really live and thrive off of the interpersonal relationships that I have with my students, especially the ones that I already know. And so I was really looking forward to seeing you guys in class again. And I know that's probably why you chose my class, because you wanted to see me in class, not because you like statistics. I mean, it's great, but I mean, bye. Have a Merry Christmas.